Hello all, this is Mr. G, and in this video we're going to do a review of ratios, proportions, and similarities. So let's not waste any time, let's jump right in. Let's take a look at numbers 1 and 2. We got to fill in the blanks in each proportion if a to 7 equals 3 to b. And number 1, it says b to 3, so b over 3. So essentially they're asking us to rewrite this proportion. Now the way I do it, okay, so they're giving us b to 3. So that would be, okay, so that's b to 3 like that. So we need to follow that same pattern on the other side of the proportion. So that would be 7 to a. So I put 7 over a as my answer for that one. And let's take a look at number 2. Oh, I guess I should actually check the answer. Okay, so far so good. And 3 over a. Okay, so that's 3 to a. So we have to do the same exact pattern on the other side of the proportion. So that'd be b to 7. So we'll put b to 7 and check our answer. And there we go. All right, number 1 and 2 down. Take a look at number 3. Find the value of all variables. Now, if we're looking at these two triangles, immediately I notice we've got one pair of congruent angles, the right angles, and another pair of congruent angles. If we ever have two pairs of congruent angles in two triangles, that means they're similar. That means we can make a proportion. So that's what we're going to do. There's a few different ways you could do this. I like to start with my variable. I'm going to start with W. Let's go W to 7.2, sort of staying in the same triangle. Now we're locked into that pattern. So W to 7.2. In the other triangle, let's see, W is between this angle and the right angle. So that would be, what matches up with that? So that's 15. And what matches up with 7.2? 7.2 touches the blank angle and the 90 degrees. So that would be 12. That matches up with 12. We don't need those markings in there anymore. So 15 to 12. I'm going to double check myself one more time, just make sure it looks good. So W to 7.2 and 15 to 12. Yep, that looks like the same pattern. I know it seems kind of silly for me to double check my proportion, but this is the most important part. After this, it's seventh grade work, so we got to make sure this proportion is correct. And then we can just cross multiply. I'm going to use the shortcut and just do 15 times 7.2, multiply the two that are diagonal, and then divide by the third one. I'm going to hit divide by 12, and we get 9. So W equals 9. Check the answer, and we're good. Number 4. Again, find the value of all variables. And we see something very similar, ironically, as we saw on number 3. We see two pairs of congruent angles. I guess I can color code this to make it more obvious. So we've got two pairs of congruent angles, which again means these triangles are similar, which means we can make a proportion. Again, I'm going to start with the variable. So I'm going to go x. Let's go triangle to triangle this time. So it's x to, what would that match up in the other triangle? You might be tempted to say 36, but that's incorrect. X does not match up with 36, even though they're both the left side, because x is between these two markings and that one marking. And 36 is between one marking and a blank angle. So it doesn't match up. The side that does match up, that has the two angle markings and one angle marking, would be right there, 45. So it's x to 45 would equal, and the only other option we have in this triangle is 24, because we've locked ourselves into the small triangle to the bigger triangle. So it's 24 over 24 is in between one angle marking and a blank angle marking. So let's see, one angle marking and the blank angle marking, that's 36. 24 to 36. Then we can just cross multiply the two that are diagonal. So it's 24 times 45, divide by 36, and we get 30. So x equals 30. Check the answer. Beautiful. Number 5. Again, finding the value of all variables. This problem is slightly different. We only have one shape. So we're not going to look for, at least I'm probably not going to look for like two congruent angles for the two triangles to be similar, but we actually have two congruent angles right next to each other, which means this segment is an angle bisector, which means we can use the triangle angle bisector theorem, which essentially means we've got a shortcut to a proportion. Again, there's a few different ways to do this. I'm going to go n to 21, n over 21 equals, let's see, so n to 21, we have to do that same pattern on the other side. So that'd be 51 to 22. 51 to 22. So n to 21, 51 to 22. Looks good. Cross multiply, so it's 21 times 51, divide by 22. I don't know what happened there. There we go. And we get 48. Wait, what is that? 48.681 and the 8 1 is repeating? Is that the answer? Oh, okay. I just rounded it to 48.68. Okay, yeah, I guess we can just round it to two places. I would accept either of those answers, but yeah, we'll just leave it like that since that's what the answer key says. Let's take a look at number 6. Okay, again, slightly different. We don't have two separate shapes here, and we don't have an angle bisector, but we do have parallel lines. We have a parallel line essentially splitting the other two sides of a triangle. So like this side of the triangle and this side of the triangle are split by this parallel line, which means we can use the side splitter theorem to find one of the missing parts of one of these split segments. That's how this works. But again, all that jargon just means we've got a shortcut to a proportion since we're not looking for one of the parallel lines. If we're looking for one of the parallel lines, it does get more difficult. But here we're not. So we can just go 58 to C. 58 to C equals 72 to 84. That's one way to do it. Not the only way, but it's the way I'm doing it right now. And then we cross multiply 58 times 84. Divide that by the third number, which is 72. And we get 67.6 repeating. And we're right. Excellent. Number 7, same directions, trying to find any variables, or rather the value of any variables. Okay, we've got another angle bisector here, which means it's a triangle angle bisector problem, which just means we've got a shortcut to a proportion. I forget how we did it last time. I was going to try and do it differently, but whatever. It really doesn't make a difference. I'll start with K to 25, I guess. That's one way to do it. K to 25. Oh, I think that is the same way I did it. So let me do it the other way then. So let's go K. The other thing we can compare K to is 14. So we can go K to 14 equals, and if we go K to 14, then we have to go 25 to 12. 25 over 12. Just matching that same pattern in both of our ratios, both of our comparisons. Then we multiply. 25 times 14. Oops, let's correct that. 25 times 14. Multiply the two that are diagonal. And then divide by the third one, which was 12. And we get 29.16, and the 6 is repeating. Excellent. So far, so good. Number 8. Okay, we've got parallel lines, which means we should be on the lookout for the side splitter theorem. But we're not going to be able to use the side splitter theorem for everything here because we notice we have x on one of the parallel sides. So unfortunately, we're not going to be able to use that side splitter shortcut for everything here, but we can use it for y. So let's do that. Let's do the easy one first. So let's go y over, let me see. Let's go y to 68 equals, and if we go y to 68, then we want it to be 7 to 11. 7 to 11. Y to 68, 7 to 11. That looks good to me. Then we cross multiply, so it's 68 times 7, and divide that by 11. This is definitely going to be something repeating. Yeah. Y comes out to 43.27 repeating. Now we just have to find x. And like I said, x is going to be more difficult here because now we have to worry about the two triangles. So it can be helpful sometimes to actually separate the two triangles, but I don't think we need to do that. Like for example, let me write x over here. So what can we compare x to? And I'm going to stay in the same triangle this time. So I'm just focusing, let me do this in green. I'm just focusing on this triangle. So we could compare it to either we could compare x to either y or 68. I think 68 is going to be easier since, I was going to say since we know it, but we actually know y as well. But I mean, I don't want to deal with a repeating decimal unless we absolutely have to. So let's use 68. So we're going x to 68, which means we are locked into this pattern. We're locked into this side of the triangle to that side of the triangle. So we have to do that same exact pattern we did in the small triangle to the bigger triangle. Let me get this green out of here. I guess we're going to use green again, though. What would match up with x? So this side would match up with 81. So we're going 81 over, and what would match up with the 68 in the big triangle? You might be tempted to say 11, but that's incorrect, unfortunately, because if we go 81 to 11, that doesn't match. That doesn't match, we'll do this in purple, I guess. That doesn't match this whole side to that whole side because 11 is not the whole side. We have to do this entire distance. So it's got to be 81 to 68 plus 11, which would be 79, if I'm doing that correctly in my head. I'm pretty sure I am. And now we can cross multiply. So 81 times 68, divide by the third number, which is 79, and we get 69 point, what is that, 72? X equals 69.72. We check our answers. Oh yeah, that should be an approximate because I did round there, didn't I? Yeah, that was my bad. So X is approximately 69.72, and Y is exactly 43.27, repeating. Number 9. In this diagram, I see parallel lines. Okay, there we go. We see 3 parallel lines, which means we can use the side splitter theorem. Just because there's no triangle here doesn't mean we can't use the side splitter theorem. And I would actually argue that there is a triangle here because these arrows mean the lines keep on going. So eventually they will create a triangle. So this is just the side splitter theorem, which means we have a shortcut to a proportion. How do we want to do this? We could do 29 over G equals 33 over 65. Again, not the only way to do it, but that's how I'm going to do it this time. 29 to G, 33 to 65. Okay, cross multiply 29 times 65. Then we divide that by 33, and we get 57.12 repeating. Both of them are repeating, right? The 1 and the 2? Yes, good. Then we just move this out of the way to check the answer, and we're good. Excellent. Scroll down so we can see the rest of these problems for this review of similarity ratios and proportions. Number 10. Oh boy, okay. Same directions, but as soon as I see this diagram, I think, all right, this is one of the more difficult problems because here we don't have any parallel lines. We don't have an angle bisector inside this triangle. What we have inside this big right triangle is an altitude drawn in. Remember, the altitude goes from a vertex to the opposite side and creates a 90-degree angle. So this segment, which Z is on, is an altitude. Anytime we have an altitude drawn inside a right triangle, we don't just have one right triangle anymore. We've got 3. We've got the small right triangle, we've got the medium right triangle, and we've got the big right triangle. Which means, and I shouldn't say it that way, and in addition to just having 3 right triangles, we have 3 right triangles that are similar, which means we can create a proportion here. There's actually a bunch of different ways to do this. I'm not sure how much time I want to spend on this one slide though. Basically, there's 2 options here. You can redraw the triangles. So short leg, long leg, hypotenuse, short leg, long leg, hypotenuse, short leg, long leg, hypotenuse. Sort of started there, but whatever. And sort of bring out the information and fill in everything there. That's one way to do it. Or you could look for our geometric mean shortcut, where it's one side of the hypotenuse to the altitude, and then the altitude. Let me do this in a different color, actually. So let me start over. So one part of the hypotenuse to the altitude, and the altitude to the other side of the hypotenuse. So if you ever see that, you have 2 parts of the hypotenuse and the altitude, or at least 2 numbers and a variable on those 3 segments, you can just make that geometric mean proportion, which would look like this. It would be 12 over Z equals, let me draw that better, 12 over Z equals Z to 48. And then you can just cross multiply. And actually, once you find that number, you could just use the Pythagorean theorem to finish this. So there's a lot of different options here. So once you know what Z is, you can just do, I feel like this is getting messy. Like once you know Z, then you could just do like a squared plus b squared equals c squared to find y. And you could also do a squared plus b squared equals c squared to find x. All right. So if you're someone who likes to do this the shortest way possible, that's probably the fastest way. Geometric mean, shortcut, and then the Pythagorean theorem. But let's say all that was gibberish. Let's say you're watching this video and you're like, whoa, Mr. G, you lost me like 45 seconds ago. In fact, I've just been skipping ahead to trying to get to the next problem. Let's say you're in that situation. All you have to do is this. Just separate your 3 triangles, and that's the way I'm going to do it because that's what I think will be most helpful to most students watching this. Let me take a look. So in the small triangle, actually tell you what, let's take this a step further. Let's color code these. Why not? So we'll do the small one in blue. That one's right here. So on the small triangle, I see 12 on the short leg. I see, well, the 90 degrees right there. So Z is the long leg, and X is the hypotenuse. Remember, the hypotenuse, let me do this in a different color. The hypotenuse, we always can treat, no. To find the hypotenuse, that's what I meant to say. To find the hypotenuse, we can treat this right angle like it's an arrow pointing at the hypotenuse. So if you ever have trouble finding the hypotenuse, use that trick. Now let's do the medium one in green, short leg, long leg hypotenuse, which is right here. The short leg will be Z, and I'm going to use that 90-degree trick, again in a different color. There's our 90 degrees. We're going to treat it like an arrow pointing at the hypotenuse, which means Y is the hypotenuse and 48 is our long leg. We don't need that arrow in there anymore. And last but not least, we've got the whole thing, the big triangle. I forgot to write it over here. Let me get my face out of the way. So short leg, long leg, hypotenuse. The short leg is X, the long leg is Y, and the hypotenuse is 48 plus 12, that's 60. 48 and 12, that's 58 and 2, yeah, 60. And now, we don't even need to look at this diagram anymore. You don't have to look over there if you don't want to. Everything you need, let me get rid of that, everything you need is right here. Because now you have three separate, similar right triangles, which means you can just set up three proportions. I'm going to actually move these over so I have more room. Yeah, that's what I wanted to happen. More room to show my work. I think that will work nicely there. All right, so let's scroll. No, actually, we can't scroll up because then my face will be in the way. That's okay, though. Let's do X first. Oh, I actually don't know if I want to do this in blue. Whatever, I'll just do all the proportions in purple. That's fine. At least I think it's purple. Whatever, we don't need to know about that. Let's do, I actually don't care. What do I see first? I'm looking for any, I see Z's. So here we can go like 12 to Z equals Z to 48. And now I'm just realizing that's the exact same proportion I wrote down 2 or 3 minutes ago when I was talking about the geometric mean shortcut. So here, I'm actually lucky, I'm happy rather, it worked out this way. Because you see, whether you do it the geometric mean shortcut or you draw out your three triangles, you can still get the same proportion and the same answer. It works either way. And then we just cross multiply. We cannot use the shortcut here because Z times Z, that's not the color I want. Z times Z is Z squared. Let's write that a little bit better. And then 48 times 12, I'm not doing that in my head. 48 times 12, we get 576. And then we're going to take the square root of both sides to cancel out that power of 2. And we get Z is, I'm going to show you a shortcut here. I'm going to hit second and then the square root button. And then I'm going to hit second. And you look, if you look at right above the negative button, it's right about here. I can't like drag this arrow over all the way. But if you look at the negative button, I'm going to hit it right there, the one that just highlighted. It says A and S if you do second. That means answer. So essentially, it's going to say, okay, I'll find the square root of whatever you just had. And the number I just had was 576. And we get 24. Okay, so we can keep it equal. So Z equals 24. Now we're going to do the same thing for X and Y. I'm not sure if we're going to need that number, but I'm going to write it in just in case. So Z is 24. We can put that there. Whatever. And here, I'd like to try and find the rest of it without using that 24, but it's there if we need it. What do we see for Y? Okay, I see a Y and a 48. Can I do that same pattern anywhere else? Yeah, 60 and Y would match up. So I can do Y over 48 equals, what was the other one? 60 over Y. And that's what these problems are all about, just looking for different patterns. Like, I truly, when I wrote this down, I did not see the 60 over Y. I was just like, all right, I see a variable, I'm looking for Y and a number next to it. Let me just look if I can see this pattern anywhere else with either two numbers or the same variable Y and another number. That's what you're looking for. Like, you wouldn't want to do it up here. That would be no good because then it'd be Y over 48. Let me actually write this up here in red in case this is helpful. Then it'd be Y over 48 equals X over 24 because we know Z is 24, but that's no good. We've got a Y and an X. So, you just sort of mess around, try different things till you see a pattern that will work, or rather a proportion that will work. Where was I? Right, cross multiplying. So we get Y squared equals 48 times 60. And we get 2,880. And then we take the square root of both sides. I'm going to use the same second square root, second answer trick. And this time that's going to be approximate. So Y is approximately, what is that, 53.66? 53.6, oh no, around 6.7, my bad. Okay, sort of running out of space. We'll do our last one up here. What are we looking for? We've got y, we've got z. Now we need one for x. Let me move these out of the way, erase them. So what do we see with x? I see an x here. We can go x to 60 like that. Will that match anywhere else? Oh yeah, 12 to x. Again, I didn't see that immediately. Just looking for stuff, just trying stuff. X over 60 equals, what was it? X to 60 is 12 to x. Lost myself for a second. Then we cross multiply. X times x is x squared. 60 times 12, and we get 720. Take the square root to get rid of the power of 2. Oh, I guess I should do a public service announcement. Normally when we take the square root of both sides in algebra, we have to worry about the positive or negative answer, but we do not have to do that here because we're not just finding numbers, we're finding distances. And distances will not be negative. We need to keep them positive. And this is going to be another approximate. X is approximately, what is that, 26.83, rounds down. All right, that was a long problem. Let's check the answers. Hopefully I did that correct. I don't feel like redoing this. Let's move this out of the way. Okay, we're gonna have to do a lot of moving. Let's just move the answers and check. So X, we got 26.83, good. Scroll down. Y, we got 53.67 approximate, and Z, we got exactly 24. Good, good, good. Number 11, another long one. The segment AB has endpoints A, -8, -7, and B, 4, 2. Find the coordinates of two possible locations. Okay, we're looking for two locations here. So two possible locations for a point that would separate the segment into two parts, that's important, in the ratio 1 to 2. And they give us a nice graph to work with. All right, first things first, let's graph these coordinates. Let's graph the endpoints. So A is -8, -7. -8, -7 is right here. Let me make sure I don't make a mistake. And I think that was A. That's not what I wanted to happen. -8, -7, that looks good. And B is 4, 2. 1, 2, 3, 4, and 2. Again, double checking myself. Good. And now I'm going to connect them. I'm going to cheat and use the smartboard for a perfectly straight line. If you're doing this on your own, you can use a straight edge like a ruler, or even just another piece of paper will work fine for these problems. Let's get back to a pen now so I can keep running. There we go. Where did we leave off? Okay, so we graphed the segment. Now let's pull out the rest of the clues. Okay, the big clue right here is ratio 1 to 2. So I'm going to write that over here. So it's a ratio of 1 to 2. And now we have to figure out what type of ratio this is. Sometimes it's part to part for these segment separation problems. Sometimes it's part to whole. And here it says two parts, which means it's a part to part. Which also means we need to find the whole. If they don't give you the whole, you want to find the whole. You want to find that total. So we need to add 1 and 2 to get 3. Because remember, anytime we do one of these problems to find the whole, we add up the two parts. Now we have to actually deal with the diagram because the actual distance, the actual total, the actual whole length we see is not 3 in our diagram. And it's actually kind of annoying because we've got a diagonal line here, which we can't really count. We can't just go like, okay, 1, 2, 3, 4. The only two directions we can count are vertically or horizontally, at least easily. But fortunately, we can just break this down. So it actually doesn't matter which way you do it. And I feel like I was constantly going vertical when I did this in the lesson. So I'm going to go horizontally just to show you that you can do it either way and still get the correct answer. So I started from B. It doesn't matter whether you start from B or A. It doesn't matter. But what does matter is that your distance, whether it's horizontal or vertical, would get you all the way from B or from A all the way over to being right above or right next to the other point. So like we wouldn't want to stop here. That's too short because if we go down, we're not going to hit A. We need to go, let me rewrite the whole thing. We want to go all the way over to here because now we're right in line with A. We just have to go straight down. So you actually could draw both. You could draw the horizontal and vertical, but you really only need one for a problem like this. And now we need that distance. So let's see, what was that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's a distance of 12. I'm going to put that right there. And I'm going to put it here. Because that is the total horizontal distance. That's the whole distance, at least for the horizontal component of our diagonal line. And now, okay, now it's time for the most important part. How do we get this ratio to match what we're actually seeing in the diagram? Well, to get from a 3 to a 12, we have to multiply by 4. So that's what we're going to do. And if you ever don't see that, just take the bigger one, which is 12, and divide that by the smaller one, which was 3. and that'll give you 4. That'll give you what you're multiplying. Essentially, your scale factor almost, if you've heard that phrase before. If you haven't, don't worry about it. It's fine. Now we're going to do that same thing times 4 to our two parts of the ratio. 1 times 4 becomes 4. 2 times 4 becomes 8. And we can double check ourselves. Oh, that should be green. My bad. 4 and 8 it was, multiplying by 4? Yeah. And we can double check ourselves to make sure that these two add up to 12. And they do. 4 plus 8 gets us to 12. Now we're just going to count over. And it actually said we're looking for 2 locations, right? Yeah, so we can either count 4 or 8. I'm going to count 4 because it's less to count. I'm going to go 1, 2, 3, 4 in this direction to get this coordinate. And I'm going to go 1, 2, 3, 4 in this direction to get this point. Now keep in mind, if they had not said like 2 possible locations, either one would have been fine. But if they were more specific, like, we want this ratio from A to the middle point and the middle point to B or something like that, then we'd have to be more careful about which direction we counted from and how many steps we took. But since it just said 2 possible locations, it actually made it a lot easier for us. This phrase made this problem a lot easier, in my opinion. What is next? You might be tempted to think we're done, but we're not. Because these points we found are not actually on our segment. We want something on segment AB, but all we need to do is just go down. So we have 1 point hitting right there, and 1 point hitting right there, which gives us coordinates at, the first one is 0, -1, and the second one is -4, -4. And we check our answers, which were all the way up here. -4, -4, and 0, -1. And that's what we got. Good, good, good. A few more to go, rather. And we finally made it to the word problems. All right, let's take a look. Malachi's trying to find the height of a flagpole. He knows he is 6.5 feet tall. I'm just going to draw the diagram for this while we're doing it. So he is 6.5 feet tall. That's his height. I'm not going to try and draw him. And his shadow, okay, there's the shadow, is 5 feet long. At the same time of the day, the flagpole shadow is 16 feet long. Okay, there's the flagpole shadow. And how tall is the flagpole? So the height of the flagpole is our x. Now, hopefully you see we've got 2 similar triangles here, because all we had to do is draw essentially the angle of the sun coming down to create the shadows. And we've got 2 similar triangles. And we just make a proportion. 6.5 over 5, let's erase that. 6.5 to 5 equals x to 16. Cross multiply, and we get 16 times 6.5. Divide by the third number, which is 5, and we get 20.8. 20.8, check the answer. All right. Number 13, another word problem. Again, I'm going to draw a diagram as we go. So Natalie places a mirror on the ground 15 feet from the base of an oak tree. I'm going to look ahead. Okay, it says we got to find the height of the oak tree, so I'm just going to make that x. So there's the oak tree. We don't know its height. And from the base of the oak tree, from right there, Natalie places a mirror on the ground 15 feet away. So 15 feet away. So this point right there, that's the mirror. Where was I? She walks backward until she can see the top of the tree in the middle of the mirror. So she's essentially walking back this way. That way she can look down and the line of sight will bounce the vision. Essentially what's happening is this. We've got a line of sight problem going from her vision to the mirror, then back up to the top of the tree. So at that point, Natalie's eyes are 6 feet above the ground. So there's our 6. And her feet are 3 feet from the image in the mirror. So her feet are at the bottom. So we can put 3 is right there. So 3 is the distance from there to there, if that wasn't clear. And again, we've got 2 similar triangles. Make a proportion and we're going to be done with this. X over 15 equals 6 to 3 is what I would do. And that's just going to be 30, I think. Let me double check myself though. 15 times 6, divide by 3, and we get 30. Check it, and we're good. I think we just have 2 more. All right, the school band is having a bake sale fundraiser. They are selling donuts and muffins. All right, the ratio, that's a key word. The ratio of donuts sold to muffins sold, okay, so we're talking donuts to muffins, is going to be 4 to 5. If they sell a total of, I don't know what happened there, a total of 360, we've got to find how many donuts. Okay, so we're trying to find the donuts. Now, Whenever you have a problem like this, as soon as you see the word ratio, that should be like jumping off the screen at you. Hey, you can make a proportion. Now, let me be clear. A proportion is not the only way to do this. In my experience, it's the most consistent way to do it, where it just works most consistently for me. But if you've got another method that works, by all means, go for it. But I'm going to set up my first ratio, always starting with x for a problem like this. And I'm going to do that for a reason. X, and what can we compare x to? All right, so actually, let's make sure we're keeping track of what we're comparing here. So x, what is x going to represent? That's what we're trying to find, so that's donuts. I'll just use D for donuts. Now, x is the actual number of donuts sold. The only other number they give us of something that's actually a number of something sold is 360, which is the total. So our first ratio, our first comparison is donuts to total, which means we have to match that in our second ratio. So we need a number for donuts, so we can look at our the ratio they gave us right there. So 4 is what they gave us for donuts. Now you might be tempted to just say, oh great, we just put a 5 in the denominator and we're done, but that's incorrect. Because 5 is muffins. 360 is not muffins. 360 is the total. So we don't want to use a 4 or a 5 for the denominator right here. What we need is a number in this ratio or from this ratio that represents the total. And the total in that ratio is going to be 9. If you're not sure how I got that, I just took the donuts, which were 4, or the number we had for donuts, the part that represented the donuts, which was 4, added to 5, the part that represented the muffins, and we got the whole for that ratio of 9, the total. After that, we cross multiply. The rest is 7th grade work. So we do 360 times 4, divide by 9, and we get 160. So x equals 160. Check the answer. Let's make that look like a 6. And we're good. Excellent. I'm pretty sure this is the last one, right? All blank after this? Yeah, last one. Thank goodness. Number 15. The track team. Okay, good. Talking about a group of cool people. I like that. The track team is selling turkey and Italian sandwiches at a concession stand during a track meet. After the meet, they have sold, okay, this is important. They've sold 224 turkey sandwiches. So I'm going to write that down. So 224, equals the number of turkey sandwiches. So turkey, I'll just leave this turkey. We know it's turkey sandwiches. If the ratio, we see that key word again, of turkey sandwiches to Italian. Okay, so if turkey to Italian, actually I'm going to use lowercase, turkey to Italian. If turkey to Italian is 7 to 5, I'm actually going to draw a line there to separate those two pieces of information. How many Italian sandwiches were sold? So we're looking for the number of Italian sandwiches. So again, we see a ratio. One way to do this is with a proportion, and I'm going to use x. I'm going to start with the variable, and x is representing the number of Italian sandwiches. That's what we're trying to find. Now, x is the actual number of Italian sandwiches sold. The only thing we can compare that to, well, not the only thing, but I think the best thing to compare to is 224, because that's the only number they give us. That's the number of something that's actually sold. Like this 7 and the 5, we didn't just sell 7 sandwiches or 5 sandwiches. That'd be a really lousy fundraiser for the team. But we sold 224, so let's use that. And it's 224 turkey. I'm actually going to write this out. Turk, we'll just abbreviate it. I don't want anyone to think that T stood for total there. That's what I meant to say. And okay, now our second ratio must match. It has to be Italian sandwiches to turkey sandwiches. And we can use this ratio they gave us. So Italian is 5 and turkey is 7. So here we did not need to add the 7 and 5 together because the number they gave us was not the total. It was one of the parts. Now we just cross multiply. 224 times 5 divided by 7, 7, and we get 160. So we get the same answer again. And, oh, can't read it. Still can't read it. You're killing me. Okay, well now this looks ugly. There we go. 160 Italian sandwiches. So we did get the answer correct there. Hopefully this was helpful. If you have any questions, by all means, let me know. Enjoy the rest of your day.